Hello, everyone. Good morning. My name is Meredith Muth. I am a program coordinator with NIDIS and your moderator for today. Today's webinar, we will be providing an overview of the CPC Rapid Onset Drought Risk product. This webinar is co-hosted by NOAA's National Integrated Drought Information System, or NIDIS, and the Climate Prediction Center, commonly referred to as CPC, under NOAA's National Weather Service. Next. Our overview today, in addition to providing an overview of the Rapid Onset Drought Risk product, we will also be sharing with you some future areas of product improvement by CPC based on stakeholder feedback. And finally, we want to provide an opportunity for you, the audience and users, to provide feedback and ask questions. We have three outstanding speakers today that have extensive experience in drought prediction. Brad Pugh is a meteorologist at NOAA's Climate Prediction Center. His forecast duties include week 2, week 3 to 4, and monthly to seasonal temperature and precipitation outlooks, global tropical hazards outlook, week 2 U.S. hazards outlook, and the monthly and seasonal drought outlook. So he is quite busy. He is also a U.S. Drought Monitor author and has worked with the Joint Agricultural Weather Facility for many years. We also have Adam Hartman with us today, a meteorologist at the Climate Prediction Center. He performs short-range temperature, precipitation, and hazard forecasts, long-range drought outlooks, and serves as a U.S. Drought Monitor author. Mr. Hartman is also the Climate Prediction Center's GIS manager and serves as NOAA's GIS administrator, helping to publish web services for the National Weather Service's national centers. And then finally, we have John Gottschalk, who has worked at the CPC since 2004. He is currently the chief of the Operational Prediction Branch within CPC and is responsible for preparation and dissemination of CPC operational outlooks and related activities. Prior to joining CPC, he worked at the Rosenstiel School of Marine and Atmospheric Science at the University of Miami and at NASA's Goddard Space Flight Center. Many thanks to our speakers for joining us today. Now, after all of our presentations, we will open the webinar for your questions and comments. Throughout the webinar, all participants are muted, so if you have a question for any of our speakers, please write your question in the question box in the GoToMeeting control panel. If your question is specific to one speaker, please note the name of the speaker in the question box. Now, before we begin, we have two short poll questions to better understand who is our audience today. Adam, can you please launch the first poll? This question, where do you work? We know that some of you work in multiple entities, so feel free to select one or more of the following. We'll give it another 10 seconds. Okay, great. Adam, can you please show the results of the poll? Excellent. I imagine many of the federal government here today is from the National Weather Service, NOAA, and the U.S. Department of Agriculture, who I know is extremely interested in this product. And it's also great to see really good representation from state entities. So thank you. Adam, can you please start the next poll? Great, so this question is, how do you use early warning information, outlooks and predictions for rapid onset drought, also commonly referred to as flash drought? So feel free to select one or more of the following, and we'll give that a minute. Great. Adam, can you please share the results of the poll? Oh, this is excellent. This is really good to know for the speakers that information, early warning information in particular for rapid onset drought is used in a multiple ways. So thank you again for taking the time to answer those questions. And now we will go ahead and jump right back into our webinar. Before we get into the product that we'll be talking about today, I wanted to provide a very brief background on the National Integrated Drought Information System. NIDIS was created by congressional law in 2006 with a mandate to help the nation prepare for, mitigate, and respond to the effects of drought. NIDIS coordinates and supports efforts to improve drought prediction, forecasting and monitoring, and collaborating with existing programs and partners to undertake applied research and drought planning and preparedness. Now, the work undertaken by NIDIS, whether it's at national, regional, state, or local levels, is informed directly by the needs of the drought community. Next. Now, over the past few years, there has been increasing interest and indeed concern about rapid onset droughts, again, commonly called flash droughts, by our NIDIS partners and other stakeholders. So to address this interest, NIDIS has invested time and resources over the past 2 years to help organizations and individuals such as yourselves and those on the webinar today to better prepare for future rapid onset droughts. So on this slide, you'll find a list of priorities that have been developed by NIDIS based on feedback from the flash drought community and that we are implementing in close collaboration with many partners. For tool development, we have initiated a series of new research projects on flash drought, including a multi-year partnership with the Climate Prediction Center, as well as several university-based research programs. For information sharing and stakeholder outreach, we have been having regional dialogues at individual regional drought early warning system networks, webinars such as this one, and we've also created some guidance materials, for example, a list of flash drought tools, and we will be hosting an upcoming national workshop, so more to come on that. I encourage attendees of this webinar to explore the flash drought page on the U.S. Drought Portal at www.drought.gov, and I'll put that link in right now for everyone to see, as well as, in particular, our flash drought portal, which includes a number of information you might find handy, including causes and impacts of flash drought, key documents and presentation recordings, including a 3-part flash drought webinar series, and 2 resource documents, such as a compilation of existing flash drought tools and a list of advantages and disadvantages of each of these tools. We hope you'll find this useful. Next slide. I will now turn controls over to my colleague, John Gottschalk from CPC, who will kick off the presentations from the Climate Prediction Center.
Thank you very much, Merida. As she mentioned, this is John Gottschalk at the Climate Prediction Center. I just wanted to spend 1 or 2 quick minutes discussing CPC's mission and the type of services we provide. I know many folks on this call are well aware of some of the products and services that we do provide, but just in case others are not as well understood with respect to what we do, I wanted to give a very short mission statement of the things we are doing. So basically, CPC's mission is to deliver real-time products and information that predict, assess, monitor climate variations on timescales from just a few weeks out to about a year with respect to our seasonal outlook product package that we release each month, with the goal, of course, of promoting effective management of climate risk with the ultimate goal of improving decision-making for a number of different sectors, both from domestic and international presence, which is noted there. And these 3 particular images, the website's there, and these 3 particular images, 2 of which are actually on the shorter-term horizon, which is the week 2 period for mean temperatures for the week 2 period on the left-hand side, focusing on extremes with our week 2 U.S. hazards outlook, and in the middle is some of our monitoring products that we support and work with the Joint Agricultural Weather Facility on. In this particular case, the percent of normal precipitation. And if you go to the next slide, just to try to introduce what Brad will be talking about and Adam moving forward with the product, is that CPC obviously does quite a bit of drought-related information as part of our overall mission. We do monitoring of various quantities related to drought, the physical quantities of soil moisture anomalies, as an example shown in the upper left, as well as work very closely with partners and multiple agencies in producing the U.S. Drought Monitor, an example there on the lower left, in which we have input from a number of objective and subjective information, as well as input from all kinds of folks and entities across the field. And we also do, on the upper right, as I mentioned, outlooks. And this on the upper right is an example of the U.S. Monthly Drought Outlook released this past October 31st. And it has various categories, as many folks are quite aware of. The idea of this particular product that we're going to be talking more about during this webinar was that we had, there was concerns about the monthly drought outlook not having a high enough or fast enough tempo to target and assess and predict reliably some of these short-term drought events. And so, as I mentioned there on the bottom with the text, the drought can develop quickly within 2 or 3 weeks or within a month. And stakeholders identified a need for more frequent drought predictions, as we did as well at CPC. And so we moved forward with outlining an approach to identify potential, what we call rapid onset drought events as part of the CPC We2 U.S. Hazards Outlook. And Brad will talk much more about that moving forward. So I'll go ahead and shift it over, transfer it over to you, Brad. Thank you.
All right, thank you, John. And thanks everybody for attending today's webinar. Put it in slideshow here. Yeah, so I'm Brad Pugh, meteorologist at the Climate Prediction Center. Also want to acknowledge Adam Hartman, who was kind of the co-lead on this project, the inclusion of rapid onset drought to the week 2 hazards. And as a longtime forecaster, both week 2 hazards and drought, I've been very excited to launch this product over the past summer.
Adam, I just want to let you know we can't see your screen yet.
Hey, Meredith, can you see my screen?
Yep, perfect, thanks.
Oh, okay, great, thank you. All right, so before we get into the details of the rapid onset drought product itself, I do briefly want to just go over the week 2 hazards. I'm not sure if everybody's too familiar with this product, but since rapid onset drought is kind of the landing spot in the week 2 hazards, we're using it as a means of communication. I do want to real quick go through the week 2 hazards. We have a number of variables we forecast for, including temperature, precipitation, snow, and winds. And all 4 of those parameters are probabilistic with a slight, moderate, and high risk. And we have forecast tools, GFS and European-based objective tools for those probabilistic variables. And really the primary goal in the week 2 hazards is to identify hazardous weather climate risk at the week 2 time lead. And those risks span from anything from summer heat waves, Arctic air outbreaks, atmospheric rivers along the West Coast, and winter storms. And actually I have an example here of our hazards that was released yesterday on the right-hand side there. We've been communicating this out since last week. Good bed of Arctic air outbreaks starting later this week and continuing well into next week. So you can see the high risk of much below normal temperatures we had on yesterday's hazards map for the north central U.S. A couple of other parameters, flooding and rapid onset drought, are categorical, so they're not probabilistic. In the future, the rapid onset drought may become probabilistic, kind of working towards that, but right now it's just categorical. And our week 2 hazards is released each weekday afternoon around 3 p.m. Eastern time. So what was the motivation for including rapid onset drought risk to the week 2 hazards? First, just, feedback from stakeholders. Have a more timely product. We have the monthly drought outlook, but that's only released at the end of each month. So we have the chance to better identify the risk of rapid onset drought later in the month with a more frequent update. And also wanted to apply the tools and methodology used for the monthly drought outlook to implement the ability of a rapid onset drought forecast to the week 2 hazards when conditions warrant. And the real motivation here was to use a skillful temperature forecast at the week 1 and week 2 time scale. To show these risks for rapid onset drought in the week 2 time space. Once again, improve communication of that risk throughout the month, not just at the end of the month. And the Climate Prediction Center's major role in decision support services is really the week 2 hazards. We have a daily briefing. We also have a briefing to headquarters twice a week, and we communicate frequently with regions when there's a week 2 hazards thread on the map. So what are our inputs to the tool itself? First off, initial conditions are obviously very important. Soil moisture, we also consider 2 to 4 week precipitation deficits. EDDI, evaporative demand drought index, that's a very helpful tool to identify potential target areas. And in terms of forecast parameters, for week 1, we use positive temperature anomalies and 7-day negative precipitation anomalies from the Weather Prediction Center. And week 2 is CPC's 8 to 14-day temperature and precipitation outlooks. Temperature where there's elevated probabilities of above normal temperatures, and precipitation is where we have elevated probabilities of below normal precipitation. And on the right-hand side here is just a snapshot of the GIS project that we use, and different layers a forecaster can turn on and off to get a better idea which area to target for the potential for rapid onset drought. So the next slide here is just an example of the automated tool we have within CPC. On the top there, this is from late February of this past year, valid for March 3rd through the 9th. So using the temperature and precipitation forecasts over the next 2 weeks, plus initial conditions, the automated tool was kind of highlighting these areas stretching from the eastern Carolinas southward towards the Gulf Coast of Florida. And you can see here on the bottom, the U.S. Drought Monitor from February 22nd to March 8th. See how we did have some areas of D1 development in parts of the southeastern U.S. kind of coinciding with that, but where the tool was showing a risk of flash drought or rapid onset drought. All right, so now I'm just going to go through 3 cases that I selected from this past summer. They vary from a geographic region, the Southeast, Southern Plains, Ozarks, and the Western Corn Belt, just to kind of give you a feel of how these forecasts are made, what we're kind of looking at, especially at the week 2 time scale, since we're heavily using the temperature outlook at the week 2 time scale, especially. So the first case here was a forecast made on June 13th. And you can see in the shading here, we were posting a rapid onset drought risk for parts of the southeastern U.S., also Louisiana, eastern Texas. In the upper right-hand corner is the 500 millibar height anomaly map for that same day. So we are looking at anomalous ridging centered across the east central U.S., and that translated to large probabilities of above normal temperatures over the south central and southeastern U.S., and also led to slightly elevated probabilities of below normal precipitation in those same areas. So with the knowledge of initial conditions and then the forecast over the next 2 weeks, we came up with this area of rapid onset drought risk in the southeastern U.S. And just to kind of give you an idea of how the drought picture changed from mid-June through early July. Have a snapshot of the U.S. Drought Monitor, valid June 14th on the left and July 5th on the right. So we definitely had a expansion and intensification of drought conditions over the southeast, and had a 2-category change within this 3-week time span. So certainly goes along with a rapid onset drought, the 2-category change in just 3 weeks. You can see how parts of Georgia, upstate of South Carolina, went from D nada to D1 and even D2 in parts of northern Georgia. Now, the next case here is really in my opinion, the number one rapid onset drought case we had this past summer in terms of impacts over the Ozarks region and the Southern Plains. So back on July 11th, we had an area of rapid onset drought risk posted for parts of Missouri, Arkansas, and Oklahoma. During the week 2 time period, the 500 millibar height chart here was showing anomalous ridging over the plains, large probabilities of above normal temperatures throughout the central U.S., including that area in Oklahoma, Missouri, and Arkansas, and also elevated probabilities of below normal precipitation. So I do want to show this kind of just to emphasize how important the temperatures are to the rapid onset drought. This is the 14-day mean temperature anomaly ending on July 25th. So you can see in that area of southwest Missouri, western Arkansas, Oklahoma, positive temperature anomalies were more than 4 degrees. So over a 14-day period in midsummer, these are very large positive anomalies indicative of a very hot pattern we had during mid-July, and really accelerated the onset of drought in that part of the country. And next slide here is just the U.S. Drought Monitor, July 5th through the 19th. So you can see how we went from areas in parts of Oklahoma, Arkansas, even western Missouri that were free of drought as of July 5th. And just 2 weeks later, not only in D1, but some of these areas were in D2. So you had 2 to 3 category degradation and drought in just a 2-week time span. And on the bottom here is the 4-week U.S. Drought Monitor class change map. And much of this occurred really in a 2 to 3 week time period, early to mid-July. So yeah, very widespread 2 to 3 class degradation in the drought conditions focused on that Ozarks, Southern Plains region. during early to mid-July. And just last one I wanted to show was over the Western Corn Belt. We had a rapid onset drought risk posted back on August the 1st. On the same day, you can see the 500 millibar height chart was showing anomalous ridging centered across the north central U.S. And going along with that had above normal temperatures and below normal precipitation favored. And the rapid onset drought risk verified over southern Iowa especially. We went from D0 to D2, so had a 2-category degradation in just a couple of weeks from July 26th through August 9th. So a few of the key takeaways I came away with as a forecaster. The major event over the Southern Plains, Ozarks region verified quite well. And we had a number of other skillful forecasts across the southeastern Corn Belt this past summer. We did tend to have a higher false alarm rate back in the late spring and also September. Drought was a little bit slower to develop in those areas, or during those 2 months, more on the 4 to 6 week time span. And also we did miss a rapid onset drought event in the Northeast during late July and early August. So these are some of the things we can learn from as we head into next warm season. And the last key takeaway, and this really is, I guess, not a surprise, but certainly something forecasters are aware of, is rapid onset drought and heat waves, major heat waves, kind of go hand in hand, typically coincide. So yeah, many times when we go back to this case in July, when we had the rapid onset drought event over the south central U.S., at the same time we had pretty significant heat wave as well in the plains and Midwest. And that's all I have. I guess before we take any questions, I'm going to pass it off to John now.
Okay, thanks, Brad. You can change presenter to me. Okay, great. So I wanted to just take us through the last part, kind of summarizing the feedback we received and how we're going about addressing some of the concerns and suggestions that we received. So just as background to that, as part of the demonstration period during this past summer of 2022 with the experimental rapid onset drought shapes and the U.S. hazards outlook, users were given the opportunity to provide feedback for improvement, offer suggestions, express any concerns, and so on. And so that was really helpful. And I want to thank anyone who's on the call that was able to, whether through that public forum or other means, provided us feedback is very much appreciated and very helpful. When we reviewed the feedback that we had, there was mainly 3 areas that were identified for further attention and improvement. One, which we at CPC also recognized as we were going through the summer, there was a number of periods when we had day-to-day inconsistencies in the rapid onset drought outlook areas. We'll talk about that. Also, there was mention of some confusion about what the monthly drought outlook was and its relationship to what we were doing during this demonstration. And finally, the need for product verification and skill metrics. So one of the cases, the first main area, the daily forecast inconsistencies, as I mentioned, we also felt this way. There were times in our outlooks on the U.S. hazards that the rapid onset drought outlook areas varied considerably from one day to the next, depending on the situation in the region during the past summer. And some of these changes were clearly too large to be consistent with any typical evolution from one day to the next, even with slowly varying drought conditions, or even in this more rapid onset drought context. And I show an example from September 28th on the left and September 29th, so just one day later. And this was generally the worst case. Not all of the day-to-day inconsistencies that we noticed both internally and by other users were this large. But I did choose this one to make the point. This was one of unlikely there was changes in forecast information that led to such a large change. As you can see on the left-hand side, we had areas highlighted in for much of Missouri and parts of southern Illinois and so on. And then the very next day, we shifted that down into southern Arkansas, East Texas, and Louisiana, which was obviously quite a large switch. And so we need to minimize these changes from day to day. As I mentioned before, there were other days that were more smaller changes, but still had inconsistencies, shifting areas to the west or to the east or north or south from one day to the next, when maybe was not the best case to do that. So to handle this a little bit, and there was also suggestions about maybe less frequent issuances. So to address this issue, we have at least decided initially to issue the rapid onset drought outlook areas on the week 2 U.S. hazards outlook just once per week on Thursday. And the idea here is to coincide with the routine weekly issuance of the U.S. Drought Monitor. So that's a long time, but it seems to be a reasonable given what phenomenon we're working with. But we also want to make sure that there's times when it may be required due to unforeseen conditions or changing patterns and weather climate, where an update might be necessary within that 1 week span, and so prior to the next issuance. And so we leave that potential open depending on the situation. The second area was noted by a number of users in the feedback, confusion with respect to how this product or new experimental product, the relationship with the monthly drought outlook. And so just a quick review. I know most of you are very familiar, but the CPC monthly drought outlook is released on the last day of each month. So it's a one-time a month issuance, and it depicts the change in drought conditions that are anticipated to be in place at the end of the upcoming month. So for an example, an outlook made on October 31st, the forecast would be valid, and it would be anticipating the categories that are on the map forecast to be in place at the end of the preceding month. Not preceding, but next month, in this case, November 30th. And so with the new rapid onset drought outlooks, CPC was really trying to communicate better rapid drought development that seemed to often come in between these monthly issuances. And as Brad showed, some of these drought conditions can deteriorate very quickly within just a couple or 3 weeks. And there were times within each monthly issuance we had that occur. And so we thought with the monthly drought outlook a number of years ago that would help us to identify some of these more rapidly developing droughts. But as it turns out, that was not a frequent enough tempo. And so that was kind of the basis behind doing this with the week 2 hazards outlook that we have, which is a more frequent daily product. And one of the things that's important is that we'll be maintaining consistency with the monthly drought outlook in the week 2 rapid onset drought depictions. Well, that's going to be a major priority this coming warm season, to make sure some of the confusion here is able to be handled and to be better addressed. The final area was the outlook verification. Obviously, with any kind of experimental outlook, it's certainly important to know how the product performs when compared to ground truth or observational data of some kind. This is something certainly that we had planned to do at the end of the season, in addition to the feedback that we received from many stakeholders on this, because obviously users would like to see information and did request it, how the actual forecast experimental product is verified, to develop trust in the product and to convey forecast reliability to their stakeholders. And so this is a really important thing. And as I mentioned, we intended to do verification such as this once we had a sufficient number of samples after the warm season. And then just as an example, again, on the bottom, the U.S. week 2 hazards outlook, where again we have an excessive heat shape, as Brad noted, and then the yellow was the rapid onset drought forecast, and then what we will be doing is linking that to the U.S. Drought Monitor categories to see how the verification performs in a quantitative way. And so the criteria or the strategy at this point is obviously, as I mentioned, just at this starting point to use a U.S. Drought Monitor as the observational data set to verify the rapid onset drought outlooks. The way we've defined the verification strategy at this point is a correct forecast is counted if at a given location the U.S. Drought Monitor degrades by 2 classes, anytime within a 2 to 4 week period. Again, it's denoted by the U.S. Drought Monitor. And all the areas or pixels within the rapid onset drought outlook area on the week 2 U.S. hazards outlook will be verified, and therefore a number of quantitative measures and skill metrics will be able to be calculated, not only for a period of events, but also for the whole season. So there can be a quantitative measure of how the outlook does in simple terms, and also as we move forward with this and more complex verification strategies. And just to show 2 examples, which we're starting to work on, I want to thank Rich Tinker for this. The first example was from a forecast in the U.S. week 2 outlook from June 15th, shown on the left. On the right-hand side is the verification initial attempt at that, where the green-brown lines on the right are the flash drought or the rapid onset drought yellow areas on the left. And the areas in which did receive a 2-class deterioration in the validation period, meaning that 2 to 4 week period, are shaded red. So in this particular case, you can see there was a number of areas that degraded by 2 classes, much of which in the middle section was in our forecasted area, about half or so in the area in the southeast or mid-Atlantic region, and not so much with respect to parts of Louisiana and Texas in the bottom. So this was one particular case. The main case that Brad was noticing is shown here, just as another example from July 11th, the large single area in the Southern Plains and lower South Central Mississippi Valley. And again, the corresponding initial verification shown on the right, again with the shading, the red shading, indicate 2-class differences. So much of that area that was highlighted as circled by the brown or green contour on the right-hand image did verify for this particular case, with relatively smaller regions outside of that area to the north and to the south. And so with that, I think I will turn it back over to Meredith and others for comments and questions on any part of the webinar. Thank you.
Great, thank you so much to John and Adam. We do now have close to 20 minutes left for questions, answers, and comments. We have a number in the queue, so if you have questions you'd like to add, please just put it in the question box and we'll get to it. And also just to give you a heads up, when you close out the webinar, there will be a short survey, just 4 quick questions. Please take a moment to answer those, as those would be helpful for NOAA in terms of improving their prediction decision support products. So for the question and answer, we'd love to have feedback on number 1, do you have any questions about what you heard today? Number 2, we presented, or should I say CPC presented 3 areas of adjustments based on stakeholder feedback. Do you agree that these are reasonable solutions? Do you have any other suggestions on how to improve this experimental product? So with that, I'll go ahead and start with our questions. The first one I'm going to direct to Adam. The question is related to soil moisture. What is the soil moisture product and temporal spatial resolution used to inform rapid drought onset?
Thanks, Meredith, and thank you all for that question. So yeah, we started off initially using CPC leaky bucket soil moisture. But what we found was it lagged a bit when we started trying to predict rapid onset drought. Reason being is that it is a single layer model, and some of the rapid drying of topsoil moisture and things of that nature was being washed out. So we started incorporating other products that kind of break down those the deeper or the soil column into various depths, NASA Sport being one of them. So we started incorporating NASA Sport earlier in the summer to try to capture those rapidly drying topsoils and subsoils. Now, right now, we are not objectively blending any soil moisture products. So we're simply allowing the forecasters to choose which soil moisture they prefer to run the tool with at this time. With respect to temporal and spatial resolution used to inform the rapid onset drought, we look at anything from 30 to 60 day drought indicators and dryness, and look anywhere from 1 to 2 weeks ahead as well, incorporating those 1 to 2 week WPC temperature precipitation outlooks, and CPC as well at the week 2 period to inform the tool.
Okay, thank you. Any additional input from the other speakers? Okay, next question for Brad. Can you just clarify what definition of flash drought you were using?
Yes, Meredith. Yeah, we're using a 2-category degradation in a 2 to 4 week time span. And we're using the US Drought Monitor as a verification. So for example, if you go from D0 to D1 or D0 to D2, both of those would be hits in terms of verifying.
Great, thank you. The next question is related to the polygons that were shown in the outlook. The polygons are strangely shaped. How are these boundaries determined?
Yeah, Meredith, I can take that one. And I probably should have mentioned this. Since we're forecasting the rapid onset of drought, if there's already ongoing drought, according to the US Drought Monitor, we cut those out, if that makes sense. So yeah, that's the reason you have some of those like weird looking shapes. So if a drought is ongoing in a specific area, those aren't included in the rapid onset drought shape.
Great, thank you. Next question. I think this is more generally about flash droughts, but certainly related to this product. Is it possible or meaningful to use 1-month drought indices to monitor flash droughts? Would anybody like to address that?
Yeah, Meredith, I can take that one too.
Okay.
Oh, yeah, so yeah, I would say really one of the top tools is the 1-month EDI, the evaporative demand drought index. We use that quite often to help target what areas vulnerable to rapidly developing drought. When you have to dig into it a little bit more though from a forecaster's perspective, because you could have an area where the EDI says it's vulnerable to drought, but you could have a heavy rain event coming up over the next few days. So in that case, you wouldn't want to forecast rapid onset drought. But yeah, the 1-month EDI is, we use that quite often. Adam, did you want to jump in with anything?
Yeah, I mean, I was just going to say, in a general sense, those 1 and even 2-month drought indices, we utilize quite a bit, because a lot of this that kind of represents the antecedent dryness leading up to maybe a heat wave triggering a what we consider a rapid onset drought event. Now that might not exist otherwise, like in a wet area. So yeah, we definitely look at those 1-month and even in some cases 2-month drought indices.
Okay. Our next question is related to regionality and temperature. So in parts of the country like the Southwest, would you predict that the periods of rapid development of rapid onset drought would stay quick later in the summer as it can be hotter longer in some areas?
Yeah, Meredith, I can take that one. Yeah, the Southwest is a little tricky. With rapid onset drought, it's most common during the summer. So at that time, you have the monsoon ongoing. Obviously, the past couple of summers have been such a wet monsoon, really haven't had very many lulls in the monsoon. But yeah, I guess if you had like a 2 to 4 week lull in the monsoon or a weak monsoon, then you could see a rapid onset drought in the Southwest with the hot temperatures. But yeah, Southwest is tricky though. It's very, very dependent on the nature of the monsoon.
Okay, the next question is related to one of the case studies that you presented in terms of where the product did not do so well. And this one I'll direct to Brad. Any thoughts as to why the rapid onset drought tool in the Northeast in July and August was not detected, or why rapid onset drought was not detected?
Yeah, that's a great question. And I think the number one reason was the Northeast turned out to be much drier this summer than anticipated, and even at the week 2 time scale, it didn't look quite as dry, and just it was very very little precipitation during parts of July and August. So it just turned out to be much drier than we anticipated. So that's something we can learn from going forward.
Okay. Next one is quite interesting. Have you considered including rapidly ending drought? So is CPC?
And I can comment on this, John. Yeah, John. I mean, the quick answer to your question is in any great detail, no. But that's not something we were just focusing on the impact from the starting end, I guess, and lead time. But there's also very important lead time and impactful drought conditions ending as well. So it's a very good point. It's certainly something that we can consider moving forward, but we haven't probably done very much groundwork on that yet. Brad or Adam, do you want to comment further? Maybe you guys have looked at some of that and with some of the data that you've been using.
Yeah, so John, I mean, obviously we don't have a product per se for that, but I would also say with the monthly drought outlook, since it's only going out 4 weeks, that could be used for that purpose. For showing, we do show drought removal in that forecast, so that could be kind of used as to see what areas could have a drought ending over the next 4 week time periods. That could be helpful.
Yes, definitely. Thanks for reminding me of that. But with respect to the question, I don't think we have anything on the plan right now on the short term for the week 2 hazards outlook for a similar type shape, if you will, for the outlook that we have for the rapid onset drought. But thank you.
Yep.
I would also like to say that like precipitation is on a local basis is very hard to predict. So to be able to predict removal of drought in some areas, it would be incredibly hard to verify that. And I think we get a lot better, I would say, skill at a monthly time scale as opposed to the large variabilities you see in the week 2 time scale and trying to nail that down.
Yeah, good point. Thanks, Adam.
Okay, I'm going to move into soil moisture for a moment, which is, a really important component in terms of monitoring and predicting rapid onset and flash drought. And I'm not quite sure this is actually the right audience for this question, but it's related to, does NIDIS or Climate Prediction Center adjust their soil moisture monitoring for managed soil moisture from the irrigation of agricultural lands? Many of the Drought Monitor 2 classification outliers appear to occur in agricultural lands, so is land use an additional filter? And I would also, if there's others who have comments on this from the audience that are working more in soil moisture monitoring or agriculture, you're welcome to share information the question box. Yeah, my understanding is that, I mean, certainly there's a ton of soil moisture networks and indicators out there. I'm not quite sure. Does anybody have a comment on if those monitoring networks are adjusted during rapid onset drought? Okay, we'll skip that. And Randy, I know somebody I can go ahead and share that question with that could get you an answer. Okay, what I'd like to do now is share a couple of comments that have come in, and it'd be great to hear a little reaction from our speakers who are also US Drought Monitor authors. And so there's been a couple of folks who said that rapid onset drought product verification should use more than the drought monitor. For example, 5 centimeter soil moisture, pasture condition, shallow rooted ag crop condition. I suspect that rapid onset drought is more accurate and useful when judged against these conditions. And then again, there's another comment saying that the drought monitor was not established to handle flash drought well. So is that not a poor way to verify? Any reaction?
Yeah, Meredith, I think that's a good idea, that we may be able to use other things along with the US Drought Monitor for verification purposes. So that's certainly something we can look into. And the US Drought Monitor isn't only a flash drought monitor. It incorporates drought on many time scales. So that's important to remember. But I will say that with a number of new tools over the years, including things such as EDI, that the monitoring of flash drought or rapid onset drought has improved over the past decade.
And this is John from CPC. As a further on comment is that what we presented and discussed today was just our initial reaction and how we want a strategy for going about doing some verification of the current experimental product now. We plan to look at other methods and using other data as the question links to. So there's a lot of things on the table. And so this was just an initial shot to show some of comparison for this webinar in the short term, how some of these outlooks are doing. But we do take the questioner's point that there's other data that we'll be able to use. I'm not sure how much of some of this type of data, and we'll turn to Brad and Adam for this, that was already kind of utilized in assessing conditions from local feedback to the US Drought Monitor authors during each week. Maybe some of this information is already included in some way, maybe not directly or an objective way, but in some way of the assessment.
Okay, we have time for a few more questions, and we certainly have a few. Again, if we're not getting to it, we'll get to it via email directly to you. Since EDI was just mentioned, I'm going to jump the line a little bit. There's a question about, do you use the sub-seasonal EDI forecast as input to the rapid onset drought determination?
Hi, this is Hailan. I can address that. The short answer is not yet, but that is in our plan. So basically, currently, CPC are working with the PSL and the OWP on transitioning the EDDF monitoring from PSL and OWP to CPC. But at the same time, we're also working on producing subseasonal EDDF forecasts using NOAA GAPS V12 subseasonal forecast. So we expect to have these subseasonal EDDF forecasts ready in about 1 year. And once they're ready, we would plan to incorporate these in the product production.
Thank you. Okay, this is a question for CPC. Could you mention when the change to weekly issuance will take place?
This is John here. That will likely start right at the beginning of the next warm season. So when we do the second demonstration in 2023, that's when that will most likely occur. I don't have an exact date, but at some time at that point.
Okay, and here's another question related to timing and issuance. Someone is interested in how once per week issuance will help with the problem of flip-flopping. And so I agree you will not see the flip if there's no forecast the next day, but isn't viewing the progression of the forecast for a couple of days important for gauging the certainty and uncertainty of the forecast? Does anybody want to respond to that? You don't have to.
Yeah, Merritt, that's, I mean, yeah, I understand the point there. I guess our thinking is, though, to minimize, like, you know, flip-flops day to day, those changes, it would be better to just go with a 1 week release, but we can also make an update if needed as well. So yeah, it's yeah, something we can think about.
Yeah, and I just want to add that the flip-flopping on a day-to-day basis, having a weekly product as opposed to a day-to-day product, it's very hard to verify potentially 7 maps against a single weekly drought monitor map, if you will. So that cuts down on that type of intra-weekly, if you will, flip-flopping. If you release it once a week, you know, at the release of, let's say, the drought monitor on a Thursday, you have the latest information that best informs you for the weeks ahead, and then you have the option potentially, we haven't discussed this, but we will, of implementing an updated forecast, you know, midweek, to try to capture any of those potential, you know, variations that we deem important enough to put to, you know, add or change the map accordingly.
Okay, we have time for 2 more quick questions. The first one, how often does the area of predicted rapid drought onset change drastically from one day to the next? No definition of drastically here, but this gets to that timing and the flip-flopping.
Yeah, I mean, this is John here. I mean, I showed that example because that was one of trying to address one of the comments or areas of comments that we received from the public comment period. But I would argue that this is correct, that did not happen that much. There were times on which we did notice it internally at CPC as well, but there were many, many more times, in my view, that there was basically stable forecasts from each day to the next in a given area. For example, one of them, the main event during this particular summer, the one in the Southern Plains, Ozark area, there may be some changes from day to day on the edges and so on based on the automated tool and how we wanted to do that. But as far as the main concept, the main message, the day-to-day flipping, I would say, was pretty low probability overall in my view. I just wanted to address some of the comments that on some days that did happen. So I would say that trying to answer this question is that it was not a trend or a major theme. It was just something that we will have to make sure we address and are careful about. So thanks.
Thanks. Adam, can you go to the next slide, the last slide? I think it's a great time for us to wrap it up. We've used our full hour. We still have a couple more questions. Just a quick reminder that a webinar recap and recording will be emailed and posted on drought.gov with key takeaways. Feel free to share it with your colleagues. Again, a short survey will come up and pop up. Please take a moment to fill it out. That would be really helpful. We'll also provide you with links for additional information on the product that was presented today. If you have additional questions, please contact Brad and Adam, and we'll have that information for you as well. And again, just a reminder, if you want additional background information on products, tools, etc. on flash drought, please go ahead and check out our flash drought page on drought.gov. And on behalf of the amazing crew at the Climate Prediction Center, I'd really thank you again for joining us today on your morning. And if you have any additional questions, feel free to reach out. Take care.